Hi there, fellow humans.
Hi there, fellow
this
humans.
stage of your YouTube
I see you've
downward
reached
spiral.
this stage of your
I'm so
YouTube
sorry.
downward
Let us take a few minutes to reflect upon your deeply personal journey. Okay,
Let's
that's
take a
enough.
few minutes to
We're here to
reflect
talk
upon
about
your
science,
deeply
specifically
personal journey.
about frame of reference.
Okay, that's enough.
As a science
We're
student,
here to
I
talk
spent
about
countless
science,
minutes learning about
specifically about
one-dimensional
frame of
motion,
reference.
all culminating
As
in
a
the
science
production
student,
of
I
this
spent
video.
countless minutes
Your
learning
science
about
teachers will
one-dimensional
probably
motion,
spend a whole class
all
on this topic,
culminating in the
but this
production
video
of
will
this
cover
video.
the basics,
Your
so you
science
can catch
teachers will
some Z's.
probably spend.
Frame of reference relates to the velocity of an object from specific viewpoints. For simplicity's sake, I'll be using meters and seconds for all measurements. However, before we go over frame of reference, we'll need to start with the basics. There are two ways to determine how long an object takes to cover how far the object travels. The first one is scalars. Scalars are simpler and only focus on size. How far an object traveled is defined as distance. To figure out how long the object takes to travel this distance, we use speed. Speed is distance. Next, we have vectors. Vectors are complex and focus on both size and direction. How far the object travels is defined as displacement. The time it takes to cover the displacement is velocity. Velocity is displacement d. Let's run through a few examples. First, for scalars. A box is moved 10 meters in an unspecified direction with a change in time of 5 seconds. Now we have 10 meters over 5 seconds. 10 divided by 5 equals 2. Next we have vectors. A box is moved 10 meters to the right with a change in time of 5 seconds. So we have 10 meters to the right over 5 seconds. Since 10 divided by 5 equals 2, our velocity is 2 meters per second to the right. You may be thinking, the only difference between vectors and scalars is randomly sticking a direction at the end, but velocity can have many effects on our perception of reality. This is when we can actually get into frames of reference. Let's say there's an airplane traveling to the right at 270 meters per second and a car traveling 20 meters per second to the left. There are 3 ways to watch this situation unfold. One is remaining stationary outside the car and airplane. In this scenario, the velocity of each vehicle will remain the same. The second possibility is riding in the car. Now, the car is stationary from your perspective. Since the two vehicles are moving in opposite directions, 20 meters per second is added to 270 meters per second, meaning that from the perspective of the people in the car, the airplane is traveling. Finally, the third option is viewing this scenario from the plane. The plane is stationary while the car appears to be traveling faster. 270 meters per second is now added. Now that we've gone through the basics, I encourage you to look into different situations that could result in different frames of reference. Or don't. I won't be able to tell, and there'll certainly be a lot less effort spent on your part. Find a better YouTube video. Bye.